All right, ladies and gentlemen, this is the problem set that's on page 42, right? Yeah, page 42. We're going to look at numbers 60 through 84 evens. These are all factoring problems. You have to identify what the situation is and then figure out how best to factor it completely. I'm going to move through them pretty quickly. So without any further ado, let's go. Go ahead and write in green. Sounds better. Okay. Every time I see two terms, I'm always thinking sum or difference of two cubes, difference of two squares, and this isn't. This is a sum, so it can't be difference of two cubes. And so because it's not, can't be difference of two squares. It could be the sum of two cubes, except these aren't any two things cubed. I see an x cubed, but then by the time I factor that out, it's not going to match. And so, we see here that these first few are just that factoring of what do they both have that I can take out. And hopefully you see the number 30 and the number 15, and that kind of, rings a bell. You go, wait, 15 doubled is 30. So 15 is the thing that I can take out. And then this one has x cubed, and this one has x to the fourth. So I can take out 15x cubed, which leaves me with 2 plus, and then I took out all the 15, but I left an x. So 15x cubed plus 15x cubed times 2 plus x. And you can always double check to make sure you're right by multiplying this back in. And you think about 15 doubled would be 30, and it would have the x cubed by it. 15x cubed times x would give me 15x to the fourth. And so I need to be able to get what I started with. All right? Okay, next one. With this one, there's no commonality in the constants. And I think they did that on purpose just to kind of mess with you. You got a 5, you got an 8. They have nothing in common. But I do have an AB in both of these. I got a C on the second one, but not on the first one. So what I can do is I can take that AB out, and that's going to leave me with just 5 out of that first term, minus 8C on the second term. Because basically, you think about it, the AB is going to come out, the AB is going to come out, and that shows you what's left. So you should have AB times the quantity of 5 minus 8C. Okay, moving on. 64 and 66. This is when we're getting into those really simple trinomials. Those ones that we have just really mastered and seen over the last few years. What are factors of this that add up to be this? What are factors of this that add up to be this? We should be pretty good at those by now. We can do it by factor by grouping, but we don't have to. So factors of 48 that sum negative 14, I'm thinking negative 6 and negative 8. So I could say x squared minus 8x minus 6x plus 48. This is if I factor by grouping. You don't have to do it this way. When it doesn't have a coefficient off that first term, you can just identify these two numbers right here and say, okay, I'm done. X minus 6, x minus 8, okay? You could just do that. But I'm trying to encourage to factor by grouping on all of them because it just kind of helps us get in that rhythm. So it'd be x squared minus 8x minus 6x plus 48. And you'd think, what can I take out of both of these two? And I can take an x out, which leaves me with x minus 8. What can I take out of both of these two? Negative 6, which leaves me with x minus 8. And then I would get to this final step. I have x minus 6 times the x minus 8s. Okay, really simple on those. Okay, this next one, more of the same. What are factors of negative 16 that add up to be positive 6? Now notice it has to be factors of negative 16. That's important because that means they have different signs. And the same thing happened up here. You said, what are the factors of positive 48? So that means they had to have the same signs. If you multiply two things together and you get a positive, then you must have had the same sign, either a negative and a negative, like we had here, or a positive and a positive. But if you multiply two things together and your result is this negative, well then you know that one of them is positive and one of them is negative. And so I'm looking at this going, what two numbers can I get? And to get this positive 6, I would have a positive 8 and I would have a negative 2. When I multiply those two, I get negative 16, but when I add them, I get that positive 6. So again, I could just say z plus 8 times z minus 2. Now notice my 2's and my z's look a lot alike. So as a habit, I try to put that little cross bar on my z's to kind of identify them not as 2's, because otherwise these two would look identical. You do not have to do that. I'm just trying to give you insight in when I'm drawing things so you can identify it a little bit easier. Let's see. So, but I also could have done this in terms of factor by grouping, and I could have said, well, I'm going to break this up into z squared minus 2z plus 8z minus 16. I go, what can I take out of these two? I can take a z out, which leaves me with z minus 2. What can I take out of these two? I can take an 8 out, which leaves me with z minus 2. And then I have my z plus 8, that one right here. And I got my z minus 2's, and that ended up right here. Same thing. Okay, now this one has a coefficient on that first term. The coefficient is this constant out in front of that squared term. You know, this is also a coefficient. I don't want to say it has to be a squared term. But those are coefficients, and because we have this first one, that makes this special. That means we have to do factor by grouping. Otherwise, you can do the guess and check method, and there's other ways, but factor by grouping is going to be easiest. And so what we do is we always look and go, okay, this number times this number. What does that give us? 2 times negative 4 gives us negative 8. Now we need factors of negative 8 that add up to be 7. Again, factors of negative 8. If there are factors of negative 8, then one's got to be positive and one's got to be negative. And so we go, oh, it would be a positive, I'm writing with a highlighter, it would be positive 8 and negative 1. When I multiply those, I get negative 8. When I add those, I get positive 7. So now I'm going to go ahead and split this, say 2x squared plus 8x minus 1x minus 4. So what can I take out of the first two terms? I can take a 2x out, which leaves me with x plus 4. And remember, I said whenever you break this up into the 4 parts, 1, 2, 3, 4, you always, on the second half, this part back here, you're always going to factor whatever that sign is right there. So the fact that it's a negative means I'm going to take a negative what? I'm going to take a negative 1 out, which leaves me with x plus 4. See, that changes the sign right here because I factored out a negative right here. And now these two things match. So I have 2x minus 1 times my x plus 4. All right? Hopefully that made sense. Now, the funny thing is, some of you may have done this problem. I don't know that we've talked about this in class, but you can switch these two, and you'll still get the same answer. I could have said 2x squared minus 1x plus 8x minus 4. And I go, okay, what can I factor out of both of these? Well, I can take an x out, which would leave me with 2x minus 1. What can I take out of both of these? I can take a 4 out, which leaves me with 2x minus 1. And then I have x plus 4 times 2x minus 1. And look at it, it's the same answer. The only thing that's different is it's just multiplied in different order. But we know that 2 times 4 is 8, and 4 times 2 is 8. It's all the same. So it doesn't matter what order we multiply in. So just in case you're nervous about which number you should put first, don't be. Put whatever is easier first. I put the 8 up first at the beginning because I knew that the 8 and the 2 would have something in common. But you don't have to do it that way. Okay, moving on, because we got to move. 8x squared plus 10x plus 3. Again, what we multiply this and this, we get 24. Factors of 24 that add up to be 10, that's easy. 4 and 6. So I go 4 times 6 is 24. 4 plus 6 is 10. So I go 8x squared plus 4x plus 6x plus 3. That's how this works. Okay? Now factor, what can I take out of both of these? A 4x, which leaves me with 2x plus 1. What can I take out of both of these? 3, which leaves me with 2x plus 1. So then I have 4x plus 3, 4x plus 3 times 2x plus 1. There you go. Okay? Now with 72, what they did here is they tried to make it appear more difficult. This is the exact same problem we've been doing. They just spun out the order on everything. But you're still going to do it the same way and go, what are I got to multiply these two, and I get negative 36. What are factors of negative 36 that add up to be positive 5? And the answer would be positive 9, right? Positive 9 and negative 4. When I multiply positive 9 and negative 4, I get negative 36. But when I add them, I get that positive 5. And so break it up the same way. 6 plus 9t minus 4t minus 6t squared. What can I factor out of these first two? 3, which leaves me with 2 plus 3t. What can I factor out of these second ones? Negative 2, which leaves me with negative 2t. Negative 2t, which leaves me with 2 minus 3t. And then we have 3 minus 2t and 2 plus 3t. Man, it's easy to get those confused. We got so many of those similar things, but that's how it works out. So please don't get freaked out by the fact that the exponent and the term with the exponent is in the back end. You do the problem the exact same way. Math is true every time. If it worked this way, when the problem looks one way, it'll still work when the problem changes appearance a little bit. It's still true. All right, now we're kind of to the home stretch. We're back to those two terms. I see two terms, I see subtraction, that means difference. I see something being squared. I know that this is something squared. And I go, okay, so I know that 2x when squared is going to give me 4x squared. I know 5 when squared is going to give me 25. So those are the values that I'm thinking about. I'm going to break this into the conjugates. Remember, we said that a squared minus b squared would equal a minus b times a plus b. And we said that these things right here were called the conjugates, okay? Where one is minus, one is plus, and you can have it any order. And so really, this is my A and this is my B. And so I just look at this and say, okay, this is going to become 2x minus 5 times 2x plus 5. Now, does it matter if you wrote it 2x plus 5 times 2x minus 5? Of course not. You can multiply in any order. You're still just multiplying the two conjugates. Okay, so we had the difference of two squares. Difference of two squares always factors down to the conjugates. Again, we have the difference of two squares. So you say 2t is the thing that when I square it, I get 4t squared. And 3s, when I square it, is the thing that gives me 9s squared. And this is the difference. The difference. It doesn't work for the sum of two squares. It works for the sum of two cubes, but not for the sum of two squares. So then I say, all right, that means I'm going to factor this down to the conjugates and just say 2t minus 3s times 2t plus 3s. That's that simple. I mean, just factor it down to the conjugates. You can't go wrong. I mean, when you understand how simple this thing is right here and how easy it is to factor it down to conjugates, then when you look at these, the hardest part is identifying that what's inside that to square it that gives you that number. You know, what's inside this that when I square it, I get that. All right. Okay, and then we get this, again, we got a trinomial, 3 terms. So why did they throw this in now? Well, because it's a perfect square. I'm not saying I'm going to be so obvious to make it, you know, where we had this flow like this, but this is a perfect square. How do I know that? This is something squared, this is something squared, and if I take those two somethings and multiply them by each other and double it, I get this, okay? So now you could factor by grouping, you could factor, say, what are the factors of 25 that add up to be 10? Well, the answer is 5 and 5. So you know that this is going to be x plus 5 times x plus 5. Now, maybe you say you factored by grouping, and you said, well, it's 5 and 5, so I did x squared plus 5x plus 5x plus 25. I could take an x out of these, which gives me x plus 5. I can take a 5 out of these, which gives me x plus 5. And then I have x plus 5, which goes right here, and the x plus 5s go right here. And then we know that x plus anything times itself is the same thing as that thing squared. So there are all sorts of ways to have done this problem, okay? You can identify it as it is a perfect square. You don't have to. You could factor by grouping. You could ask yourself what two numbers multiply together, give me 25, and add and get 10, and you could go straight to here. But in the end, this should be your answer. But I mean, this one was, the neat thing is there's a shortcut where you can go straight from here to here, but in case you don't recognize that, it's not wrong to do the rest of the work. This one's the same way. This is a perfect square, but this one's harder to see. And honestly, this one can be difficult to do by grouping because of the two variables. That always kind of freaks people out. So I look and go, okay, r squared gives me that r squared. And 3s squared gives me that 9s squared. And if I multiply the r times 3s and I double it, I get 6rs, which is what I have here. Now the fact that it's a negative means that that 3 has got to be negative. So this has got to be negative 3s, which makes this a negative 3 there, making this a negative 6. So these are the two things, okay? So I know, now this isn't conjugate. It's not difference of two squares. This is a perfect square. I know that this is going to factor down to r minus 3s squared. That's what I'm going to get. Now you could say, well, I look at this and go, what are the factors of 9 that add up to be negative 6? Well, it's negative 3, negative 3. So I know this is going to be r minus 3s times r minus 3s. And maybe you said, well, no, yeah, but I factored by grouping. Okay, so then you said r squared minus 3rs minus 3rs plus 9s squared. What can I factor out of these two? I can factor in r, which leaves me at r minus 3s. What can I factor out of these two? A negative 3, which leaves me with, negative 3s, which leaves me with r minus 3s. And then there you go. R minus 3s gives you this one. And then r minus 3s gives you this one. And so then you get that perfect square. Okay, 2 problems to go. Sorry this is taking so long. This is clearly the difference of 2 cubes. It's the difference, and it's 2 things cubed. You got x is being cubed, and we know that 3 cubed is 27. So this is the same thing as x being cubed minus 3 being cubed. And we know, hopefully we know, that if we have a cubed minus b cubed, that equals a minus b times a squared plus ab plus b squared. All right? So just put everything where it goes, knowing that this is a and this is b. So you say x minus 3 times x squared minus, or plus rather, 3x plus 9. That's that easy. So these are really more about memorizing this formula, and if you got that formula memorized, then you can do it. All right, last one. This is the sum of 2 cubes. What 2 things are being cubed? Well, 5 cubed gives me 125, and 3y cubed gives me 27y cubed. So if I have the sum of 2 cubes, a cubed plus b cubed, that first little binomial always matches. It's the same sign. Notice up here we had a minus b, so we had a minus b. You know, we had a cubed minus b cubed, so you get that minus sign. That first one always matches. The fact that we have a plus sign here means we get a plus sign here. And then we know that there's one subtraction. So if we didn't get that subtraction out of the way at the very beginning, like we did here, then we get it out of the way in the very next term. So it needs to be a squared minus ab, and then there's 2 additions, so then the only thing left is that option. That's how I look at these 2 formulas, and I hope I'm not making foolishness. When I look at this, I go, okay, this is a minus b times a squared plus ab plus b squared. And the other one is a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Now, this is what I'm saying. Whatever sign is here, I don't like that. Whatever sign is here shows up here. The plus shows up here. The other thing I'm noticing is that there's always 2 pluses and only 1 minus. 2 pluses and only 1 minus. And so that's how I look at this. And so I know that if the 1 minus showed up at the very beginning, then the other 2 have to be plus. I know that if the plus showed up at the very beginning, then the next one's going to be minus, and then the final one's going to be plus. This is how I remember. These are little tricks I use to remember this. So now with this problem, we go, what's on the inside? Well, we're saying that this is my A and this is my B. So therefore, it's 5 plus 3y times, you got to square the 5, Now we already did the plus, we got to do a minus. Got to multiply the two. 5 times 3y is 15y. Plus, now we got to square the last one, 9y squared. And that's it. And that's as far as it goes. I know that this right here might look like a trinomial you think you can factor, or this one right here, but it's not. There are no factors of 9 that add up to be 3. Just like there, this one, you'd have to do the 25 times 9. So just trust me, it doesn't work. All right, hope that was good. Rewatch it if you need to.